There is something sitting in your kitchen right now that is slowly costing you money, and you have probably stopped noticing it. It is white. It is hard. It clings to the base of your faucet like a slow-growing crystal, creeping up the neck of the spout, narrowing the aerator, quietly reducing the water pressure you rely on every single morning. You might have cleaned it once or twice with one of those blue spray bottles from under the sink, watched it fade a little, and then watched it come back again within a few weeks. You bought another bottle. The problem returned. You bought another. You assumed this was just how things worked. You assumed you were dealing with something permanent, something that required professional chemistry, something best left to the experts and their products. What if that assumption was manufactured for you? What if the problem sitting on your faucet right now, the problem building up inside your water heater, blocking your shower head nozzles, coating your kettle element, reducing your appliances to inefficiency year after year, what if that problem had a complete, permanent solution that costs roughly $1 and takes about 30 minutes? Not a workaround, not a temporary fix. A chemical dissolution at the molecular level, the exact kind of solution that ancient engineers used to maintain the water supply of an entire civilization, the same chemistry that kept Victorian industrial boilers running safely for over a century, the same compound that every major cleaning product manufacturer quietly places at the heart of the expensive bottles they sell you again and again. The reason you do not already know this is not because the information is complicated. It is because the information is inconvenient to a $15 billion industry that depends on you not knowing it. Let us start with the white crust itself, because understanding what it actually is changes everything about how you approach it. When hard water, water containing dissolved calcium and magnesium ions, flows over a surface and then evaporates, the minerals it was carrying do not evaporate with it. They stay behind. They precipitate out of the water as tiny crystalline structures of calcium carbonate, bonding to whatever surface they land on. Each drop that evaporates leaves behind a microscopic deposit. Each deposit becomes a foundation for the next. Over weeks and months, those microscopic layers become visible crust, then stubborn buildup, then genuine blockage. The compound building on your fixtures is the same compound that forms limestone, marble, and chalk. You are, in a very literal sense, watching stone grow on your faucet. And it does not stop, not on its own, not without intervention. Left untreated, it blocks showerhead nozzles completely, reducing flow to an uneven, sideways spray that no amount of pressure adjustment can fix. It coats the heating elements inside kettles and water heaters with an insulating layer of mineral crystal, forcing those elements to work harder and consume significantly more electricity to heat the same water. Studies on water heater efficiency show that a substantial layer of limescale buildup can reduce appliance efficiency by nearly 40%. You're paying 40% more on your energy bill for the same hot water, and the culprit is not your appliance. It is what is growing inside it. In supply pipes, the deposits narrow the interior diameter over years, reducing flow to a trickle before eventually requiring professional intervention. The average homeowner in a hard water area spends somewhere around $180 per year dealing with Limescale, between replacement products, descaling tablets, and occasional plumber visits that start at $200 and rise quickly from there. Over 85% of American homes receive water with calcium levels sufficient to produce visible Limescale. This is not a niche problem. This is a near universal household reality, and the industry built around treating it generates $15 billion annually, not by solving the problem completely, but by addressing it partially, repeatedly, and expensively. Now, here's where the story gets interesting. Around 50 AD, Roman engineers were maintaining one of the most sophisticated water supply systems in the ancient world. The Pont de Garde aqueduct in southern France carried fresh water across more than 50 kilometers of stone channels, bridges, and underground tunnels. The engineering was extraordinary, but it created a maintenance challenge that would feel completely familiar to any homeowner today. Hard water flowing through limestone channels deposited calcium carbonate on every interior surface it touched. Without regular intervention, those deposits would narrow the channel over years until the water supply the city depended on dropped to nothing. Archaeological analysis of the aqueduct walls found something telling. Alongside the calcium carbonate deposits, researchers discovered traces of calcium citrate, a compound formed when citric acid reacts with calcium carbonate. The Romans had observed that acid dissolved the white mineral crust. Citrus fruit was abundant in the Mediterranean. The connection was practical, obvious, and effective. They were treating their water channels with citrus-derived acid solutions to dissolve the mineral buildup, threatening their infrastructure. They did not have a brand name for it. They did not have a subscription service. They had chemistry and observation, and those two things were enough. The same practical knowledge appeared centuries later in medieval European households, where copper cooking vessels accumulated limescale from hard water, and domestic texts described cleaning them with sour citrus rinds. Then the Industrial Revolution turned limescale from a household nuisance into an engineering crisis. Steam boilers accumulated mineral deposits on their heating elements at a dangerous and accelerating rate. A sufficiently thick deposit insulates the metal surface from the water it is meant to heat, causing the metal temperature to rise beyond safe limits, ultimately leading to catastrophic pressure failure. Boiler explosions killed hundreds of workers throughout the 19th century. Victorian industrial chemists developed systematic descaling protocols using citric acid solutions to dissolve boiler scale between operating cycles, and by 1900, the application was so well established it appeared in standard engineering reference texts across Britain, Germany, and the United States. The knowledge was in the public domain, widely understood, completely unpatentable. And that last fact is the hinge point of this entire story. Citric acid is a naturally occurring compound found in every citrus fruit that has ever grown. You cannot patent a molecule that nature produces in abundance. You cannot build a subscription business around a compound available in bulk at any grocery store. You cannot create brand differentiation when the active ingredient is identical across every competing product, and also happens to cost almost nothing. So the household cleaning products industry, as it grew and matured through the mid-20th century, did something elegant in its own way. It did not suppress the chemistry. It just made sure you never thought about it. Branded, professionally packaged products appeared on shelves. Labels featured bold warnings and scientific-sounding terminology. Marketing made the descaling process feel technical, hazardous almost, something you needed a professional formulation to handle safely. Specialized products were created for each individual application: a kettle descalaire, and a showerhead descalaire, and a washing machine descalaire, and a dishwasher descalaire, each sold separately, each repurchased regularly, each containing at its core the same fundamental compound at a deliberately modest concentration. Because a product formulated to dissolve limescale completely in a single application does not generate repeat sales, a product formulated to work partially, to soften rather than dissolve, to address the surface while leaving the deeper deposit intact, that product brings the customer back every few weeks. Pull up the safety data sheet on any major commercial descaling product. Read the active ingredients. You'll find citric acid, phosphoric acid, or a closely related organic acid compound listed as the primary active ingredient. The chemistry inside that $12 bottle is, in terms of its core mechanism, identical to what Roman aqueduct crews were applying 2,000 years ago. What you're paying for when you buy the branded product is the bottle, the fragrance, the blue dye, and the marketing budget that kept you from picking up a $3 bag of powder instead. Here is the actual chemistry, explained simply. Limescale is calcium carbonate. When citric acid comes into contact with calcium carbonate, the hydrogen ions in the acid react with the carbonate ions in the mineral, breaking apart the crystal structure that has been bonding the deposit to your fixture. The calcium ions released by this reaction combine with citrate ions to form calcium citrate, which is water-soluble. The mineral deposit that was physically bonded to your showerhead gets chemically converted into a compound that simply dissolves and rinses away. There is no scrubbing involved. There is no mechanical force required. The deposit is converted at the molecular level into something that runs down the drain. What makes citric acid superior to the vinegar, most people reach for as a home remedy, goes beyond just effectiveness. Citric acid is a stronger acid than the acetic acid in vinegar at equivalent concentrations, meaning it works faster and more completely. It is also a chelating agent, meaning it bonds to dissolved calcium and magnesium ions and keeps them suspended in solution, rather than allowing them to redeposit on the surface as the liquid drains away. This chelating property is why citric acid descales more thoroughly than vinegar, even when both are applied to the same surface. And unlike vinegar, citric acid is essentially odorless. You will not spend the rest of the afternoon airing out your bathroom. Research published in chemistry education literature compared citric acid, vinegar, and commercial descaling products on standardized calcium carbonate deposits under controlled conditions. A 10% citric acid solution at 60 degrees Celsius dissolved 100% of the test deposits within 18 minutes. The leading commercial descaling product dissolved 94% in 45 minutes. Vinegar dissolved only 67% in a full hour. The citric acid solution outperformed every commercial product tested, dissolved deposits more completely, and did it in less than half the time at a fraction of the cost. The practical applications are simpler than any branded product makes them appear. For a showerhead, you fill a plastic bag with warm water, add roughly 3 tablespoons of food-grade citric acid powder per liter, stir until dissolved, and submerge the showerhead for 30 minutes. If the head is fixed to the wall, a rubber band holds the bag in place. After the soak, run full pressure water through it for 30 seconds to flush. Every blocked nozzle clears. Flow rate returns completely. For faucet aerators, unscrew the mesh screen, drop it into the same solution for 20 minutes, rinse and reattach. For kettle, fill it to the maximum line, add 2 tablespoons of powder, bring it to a boil, and let it sit for 20 minutes before rinsing 3 times. For a coffee maker, run a solution through a full brew cycle followed by 2 plain water cycles. Internal elements descale completely. A water heater coated in significant limescale can be descaled by flushing the tank with a citric acid solution over several hours. The improvement in energy efficiency typically recovers the material cost within the first month of use. And once a surface is fully descaled, a monthly 2-minute maintenance soak prevents accumulation from returning. The annual cost of that prevention runs somewhere around $2.50. Against the $180 the average hard water household currently spends, the difference is not marginal, it is transformative. A building manager in Phoenix documented what happened when he transitioned a 24-unit apartment complex from commercial descaling products to bulk citric acid. Previous annual spend on descaling across the building, $2,400. After the switch, $47 per year. That number appears in no commercial product advertisement. It will not appear in one. What I want you to carry with you when this ends is not just a practical tip. It is a way of looking at the space under your kitchen sink, at the cleaning aisle of your grocery store, at the safety data sheets that are public documents anyone can read, and asking a question you may not have thought to ask before. What is actually in this? Why does the problem keep coming back? Who benefits from a solution that works partially rather than completely? The white crust on your faucet is calcium carbonate. The same compound Roman engineers dissolved from their aqueduct channels 2,000 years ago. The same compound Victorian boiler crews addressed with systematic chemistry every maintenance cycle. The solution to that compound is not locked behind a patent. It is not proprietary. It is not complex. It is a naturally occurring acid that costs $1 that every citrus fruit in your grocery store contains, that food scientists use as a flavoring additive because it is that safe. That has been dissolving calcium carbonate completely and permanently since before anyone thought to put it in a branded bottle and call it something else. The vault on this one has been open for 2,000 years. The only thing that closed it was a marketing budget. If what you just heard changed the way you see the products on your shelf, subscribe to Secret Fix Vault right now and share this before it disappears into the algorithm. The next vault we open holds a household problem that costs Americans $4 billion every year. The solution costs less than $5 and has been sitting in plain sight the entire time. The vault is open. We will see you inside.